Okay, I'll just have a quick one-shotted AI prompted fluid simulation I've got for you today. One-shotted, and as you can see when we click, woo, we have some fluids moving around on the screen. And look at my prompt here, because this was just happening in one shot. Create a dynamic, realistic fluid simulation using real physics equations to model the behavior. There are many papers, code examples, videos on the web and GitHub, YouTube for you to learn how to do this. I wanted it to go and do the research. Now, ran for 169 seconds, analyzed errors for 67 seconds. And look at this. Wow. And now you're thinking, okay, this just kind of looks cool. And it does look kind of cool, but we've got all these different controls. You know, we can make it more viscous, or make it take up or disappear slower so it fills up the screen, increase that so it goes away quicker. And we can make it have bigger strength, so it's bigger molecules. We can change the types, so this is water. We can make it rainbow. Let's do this so it goes away. Wow. And then it's changing colors. And fire. We bring these down. Bring that up. And we have this nice kind of cool effect that you can create. And it's kind of impressive here when you just look at it as it goes whoosh, whoosh. But I think the smoke one is the best. Wow. But we want to bring that way up. And then we can change it and bring it to whatever color you want. And it's very cool to kind of play around with. But that's not the cool thing. The really, really cool thing that I am impressed with is when we look into the code. Because I asked it to use actual physics. And so if we look here in our code that it's created for us, and we go down to use the physics, it needs to create a grid, not just draw on and dissipate randomly, but to use a nice grid, and which it is creating here, a grid resolution of n by n. 128 by 128 is what it's suggesting to use, as we can run it in JS on the CPU. But that's not the really cool thing. If we go down here into it, it's iterating over the grid here. You can see it through these for loops going over and over, and then trying to solve each of the boxes, each cell in that grid, and what color everything would be depending on how things have moved. And where we can really get it in is this code section that it created here. And when we have a look at it, we have this here. Solves linear differential equations. Now this here is the important part when it comes to fluid dynamics. I'm not going to really go into the physics of it. I don't fully understand it myself, but like this here is the equation that is important, and it actually is doing it. It's not just making it up. When I've tried to do other simulations, it would just make up the physics instead of actually bringing the correct physics in. And where here we are actually getting the correct equations in, and that's very cool to see. And then it's just more iterations of how things move around a bit, and making sure all the velocities are in the right place and how it diffuses over time. But really it is all in this equation that the cool stuff is happening. And then we have it in here in the app, we have the different colors that we can create it for it and the controls on it, but that's just standard stuff. It's really in this, which is the impressive stuff, actually putting in the physics, which is what I asked it to do. And it did it in one shot and got it correctly. And then we can see this working so well. Wow. So very impressed for a one-shotted prompt for it to be able to do this. Whoa.